Python threads don't always run in parallel, and that surprises most developers. The core decision is what bottlenecks your code. For I/O bound tasks like network requests, file reads, or database queries, threads work great. While one thread waits for a response, others keep running. But for CPU bound tasks like image processing, number crunching, or encryption, threads can actually hurt you. Here's why. Python has the global interpreter lock, the GIL. It lets only one thread execute Python bytecode at a time. So even on a machine with 8 cores, your CPU-heavy threads take turns. They never run in parallel. ProcessPoolExecutor bypasses this by spawning separate OS processes, each with its own Python interpreter and its own GIL. But there's a cost. Spawning processes is far more expensive than threads. Data must be pickled and sent over inter-process communication. Memory is not shared. For small tasks, this overhead often outweighs the parallelism gains. In practice, reach for ProcessPoolExecutor when doing CPU-heavy work. Parsing large datasets, running transforms, generating hashes. Use ThreadPoolExecutor for I/O heavy work. HTTP calls, database queries, file uploads. The rule of thumb: if your code is mostly waiting, threads are fine. If it's mostly computing, you need processes. Escape the guile for CPU-bound work with ProcessPoolExecutor, and stay lightweight with ThreadPoolExecutor for I/O. Always profile both. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.